So I thought I'd make another video about my 5-finger code finder project, the little robotic machine I built that can unlock Ford car doors that have the secure code keyless entry number keypad on their door. I figured somebody might want to build one of these or build some kind of similar button pushing robot, so they might find this useful if I discuss a little bit about how I built this thing. When I started, I actually just started with a breadboard because despite the fact that I've been tinkering electronics for probably close to 4 decades now, and I've worked for years in the field of electronics, I had never actually done an Arduino project before. I just never got around to making anything with one, so I wanted to take things a step at a time, so I just grabbed an Arduino and a breadboard. I grabbed an old character LCD that I'm sure I pulled out of some junk piece of equipment and threw in a junk bin for years, plugged that into the breadboard, and I just wired it all up exactly the way that the documentation in the Arduino development environment for the Liquid Crystal library tells you to wire everything up. Fired it up, got nothing on the LCD, and realized that I need a contrast potentiometer, so I dug a big ugly potentiometer out of my junk bin and hooked that up so I could adjust the contrast. Downloaded their Hello World program, and it actually worked. So I knew I was good there. The next step is I needed some buttons to actually interact with this thing. So I stuck down 5 buttons because I didn't really know how many I was going to need yet. Hooked those up to more inputs. Wrote some more code to see that I could figure out how to set the pull-up resistors and actually read them as digital inputs. When I got that working, I put down my favorite ULN 2003 transistor driver chip so I could actually power some solenoids. Hooked up a solenoid and got that tapping pretty quick. Then I realized I didn't really want to listen to tapping solenoids the whole time I'm developing the software, so I plugged in 5 red LEDs with current limit resistors, and I actually had something that worked here good enough that at my desk I could just fire it up and actually have it blink away and do what it needed to do for me to develop the software. I developed most of the code on this thing, but I knew there was no way it would survive a trip out to the garage, or not many trips out to the garage, hooked up to hanging on the side of a car door. So I needed to build something that would work a little bit better than this. So I started gathering up parts. I knew I needed some sort of base plate, and in the town where I live, we have a hardware store. It has sort of a junk area in the back. They have some scrap metal pieces, steel sheet and stuff, and they usually have a shelf of acrylic sheet, like plexiglass if you want to call it that kind of stuff. I think it's leftovers from some company manufacturing because they're usually irregularly shaped, holes cut out and stuff. But one day I wandered in and I found this little jackpot, which is a whole stack of little rectangular pieces that still even have the blue protective sheets on them. So that was a win. I bought that for only a few dollars, and I've used those for several projects. So I took one of those and I drilled 5 holes in it to mount my 5 solenoids, and I drilled 4 holes to mount these magnetic feet. I do have to figure out a more accurate way of drilling holes because I didn't get things lined as quite as I would have liked, and I busted this corner one out here when I was drilling, so I re-drilled a new hole up here and put this 1 foot up a little higher, which bugged me immensely, and I wanted to redo it all, but I had to tell myself that it would take a lot of time, and this wasn't a polished, production project kind of thing. It's just a proof of concept, and that was good enough. So I had my solenoids mounted, I had my magnetic feet mounted, and I actually had something that I could go stick to the car door and actually see if it looked like it might actually work. So let me do a little side here on these solenoids and actually explain how they work. These solenoids are kind of interesting because they're actually pusher type solenoids. Most solenoids are like this big thing I pulled out of a piece of equipment. When you energize a solenoid, it pulls the plunger down, which really doesn't do us much good for pushing buttons. So I needed a pusher type solenoid, and I found these at All Electronics. Their catalog number SOL-102, miniature 12 volt DC push type solenoid. They work because they have this armature in them that's just basically loose in the solenoid, and when it's back like this and you energize a solenoid, It's actually pulling on the whole thing, but because this end is thicker, has more mass to it, it actually pulls on this end more and pushes the pin that way. So if you have this up against a button and you energize it, it can push the button forward. So that's exactly what we needed for making a button pushing robot. So like I said, I mounted 5 of those on that plastic sheet. I came up with these magnetic feet using magnets also from All Electronic. They are part number mag-14, what does that say? 149. And they have an actual hole in the bottom, which you can't see because I got duct tape on them to help protect my paint job when I had this stuck to the car door. But they have a countersunk hole in them so you can put a screw right through the magnet and still have a flush surface for it to stick to stuff. I put a nut washer and a nut on the back of the magnet and then a second pair of washers and nuts on the plastic sheet so you can loosen these and adjust the height of the magnet, which was very useful because these solenoids are extremely picky about being adjusted at the exact right height to have their maximum amount of pushing. So once I had that all done and it looked like I was good there, I went and grabbed an Arduino Pro Mini and only 3 buttons because that's all I ended up using. I mounted them to the board, found a better character LCD with a backlight and better contrast, and mounted that all on this perf board. I mounted them with headers, and I even put a header on here so everything's can be disconnected because I ended up doing a little rewiring at one point and realized I should make things more modular. I put my ULN 2003 driver chip and my 5 blinky LEDs and current limit resistors here. I added a little 7805 regulator circuit to power the LCD and the Arduino off of the one 9-volt battery. I put 2 power switches. One controls power to the Arduino and the LCD separately, and then this one controls power from both batteries to the solenoids. I figured 2 9-volt batteries was good enough to run these 12-volt solenoids, but I wanted to be able to turn them off so when I was working at my desk I could just look at the blinky LEDs and not have the solenoids tapping away constantly. So I took this out, put it on my car door. I spent a lot of time playing around with it, trying to adjust the height and get adjust the height of the solenoids, get everything to work well. It just wasn't reliable. In the end, I found out that my problem was that despite the fact that I have 18 volts worth of batteries here, and these are 12-volt solenoids, that still wasn't enough power to actually push the buttons hard enough. So one day, just as an experiment, I went and grabbed a couple of my big cordless drill power tool batteries and some alligator clip wires, and I clipped them on. I pulled this battery off and I clipped one from here to here. So I had these hooked up in place of the parallel connection of the 2 batteries to the solenoids. So instead of powering them with 18 volts of wimpy 9-volt batteries, I powered them with 14.4 volts of DeWalt power tool battery. And suddenly everything started working. But that really wasn't a very convenient way to run this thing. So I ended up making myself a big-ass battery pack here with these rechargeable RC car batteries, which I got when my local Radio Shack store closed, and I got a whole bunch of stuff for almost nothing. Mounted them on a metal plate with a couple more of these metal bars to hold them in place. Later, after I almost nuked my whole project, I added a little inline fuse holder to that as well, and I put heat shrink over the terminals because I ended up dropping one of these terminals once, and it landed and hit the corner of the LCD here, and it actually kind of smoked one of the traces in there a little bit, but it didn't burn it off. I didn't actually destroy the LCD. But I decided with this much power, I needed a fuse and I needed some insulation on my terminals. I put a couple little wire hooks on here to hook onto the feet so I could just hang this whole mess on the car door. And then I can just hook these wires up here on these terminals I added later. And I'm good to go. I also added a little polarity protection diode here because I hooked that power up backwards once too and blew the top out of one of my ULN 2003 driver chips. So I had that all good to go. And it actually seemed to work pretty well. And I was tapping away opening car doors pretty quick there. Well, not really. I spent months on the project up to that point. Another little thing, though, I found at that point when I had the power to actually push the buttons is this plastic sheet was not rigid enough. You could watch the whole thing flexing back and forth, and it flexed enough that the middle solenoids weren't really pressing the buttons effectively. So I ended up adding this little metal bar to the bottom to stiffen that up. And I added this little rubber band bridge over the back because with nothing to hold the solenoids, they can just sit where they want, basically. And they work better if they're just kept up snug against the buttons while it's operating. So I put this little rubber band across the end, and I put these little plastic sticks on the end to hold it up at the right height. These plastic sticks are actually from those cheese and cracker packages. I save things like that for projects like this. So, I don't know, that's pretty much it. I wired everything in the bottom with point-to-point wiring on the perf board. And oh, one more point. These solenoids just have this sharp, oops, yeah, there you go, drop metal pieces on the powered project. These solenoids just have a sharp pin on the end. And I really was a bit worried about that poking and damaging the buttons on my door. Plus, if you didn't have them centered right on the button, sometimes they rock the button instead of pushing it. So I made these little feet. These are actually just a piece of dowel rod. I cut pieces off and drilled little holes in them and super glued them onto the end of the solenoid. And that also means that they don't fall out of the solenoids the way that one will fall out if you tip it backwards. So that was all the little pieces of the puzzle for this project put together, and I got everything working pretty good. And you can see in my other videos, I can go hook this up to the car door and hit go, and away it'll go, blinking away and tapping out all the codes that you can possibly enter on a Ford car door. And usually somewhere around 3 or 4 minutes and a maximum of 11, it'll find your code and open your car door. So if you actually build something similar to this, let me know. I'd be interested in seeing what you've done. And thanks for watching my videos.